Okay, we are going to do 11-2 notes today. Notice this says 7-2, that was a typo. Please change that to 11-2. 11-2 notes. We're doing more arithmetic sequences and partial sums. Okay, so last time we talked about sequence. Remember, a sequence is just a list of numbers. And we talked about arithmetic and geometric. Okay, arithmetic is when you have the common difference between each term. In other words, you're adding or subtracting by a common number to get to the next number there. Okay, so arithmetic, you're adding or subtracting, has a common difference. So we need to determine if this sequence is arithmetic. If so, we need to figure out what D is, the common difference. Okay, D is the common difference. So let's think really quickly. What would it take, because it's arithmetic, we need to determine if we're adding or subtracting. We don't care if it has any other type of pattern. We want to see if it's adding or subtracting. So what would we need to do to 7 to get to 11? Well, we would need to add 4. And what about from 11 to 15? Add 4. And 15 to 19? Well, add 4. Since we are adding the exact same number each time, this is arithmetic, and it said, if so, find the common difference. To complete this, we would say it's arithmetic, and the common difference is 4. All right, let's go to the next one. This here, what would we need to do to 2 to get to a -3? Well, we would need to subtract 5. All right, and from -3 to -8, that is also subtracting 5. And finally, this one is subtracting 5. Since we are subtracting by exactly the same number each time, this is arithmetic with a common difference of -5. Okay, I know fractions are your favorite, so I thought I'd throw one of those in there for you. All right. My tip with fractions is to make sure that they all have the same denominator. That really helps me. So here I see most of them have fourths. Okay, it's easier to make the denominator bigger than it is to make it smaller. So I'm going to choose my common denominator to be fourths. How can I change 1 to have a denominator of 4? Well, 1 is 4 fourths, right? What does 4 over 4 divide into? 1. So that's comma 5 fourths, comma, what would I have to do to 2 to get to 4? Well, we have to multiply by 2. So 2 times 2 would give us 4. 3 times 2 is 6. Make sure that that still reduces to the same value. 6 over 4 does reduce to 3/2. And then finally 7 fourths. Okay, so now that we have the same denominator for each one, now we can see what's going on. How am I getting from 4 fourths to 5 fourths? Well, we're adding a fourth. And from 5 fourths to 6 fourths, we're adding a fourth. Ooh, this is looking pretty good. And from 6 fourths to 7 fourths, we're adding a fourth. Life is good. This is arithmetic. I think I put too many things in there. And the common difference is 1/4. Okay. All right. Next one. What would we need to add or subtract to get from 1 to 4? Well, that looks like to me +3. All right. To get from 4 to 9, that is +5. Uh-oh. Since those aren't the same numbers, I don't have to go any further. I will. Okay. This is not arithmetic because we're not adding exactly the same number each time. But Miss Cleveland, there's still a pattern. The next one will go up by 9. The next one will go up by 11. Just because there's a pattern doesn't mean that it's arithmetic. Okay, but these numbers have to be exactly the same if we're going to call it arithmetic. Okay. All right, example 2, take a second to read over it. Find the formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. All right, so the general formula for an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 d. Okay, this right here is the nth term, meaning if this was a sub 5, that would be the 5th term. If this was a sub 20, that would be the 20th term. Okay, that's just kind of like your ending term. This right here is your first term. Oh, I smeared that. N is the same thing as this n. It's the number of term that you're on. And d is your common difference. Okay? So let's put everything into its place. Find the formula for the nth term. In other words, find a sub n equals, it's arithmetic, so we know that this is going to work, whose common difference is 3, so there's our d value, and whose first term is 2. So here our first term is 2, plus, we don't know what n is yet, so we're just going to leave it as n minus 1, and the common difference is 3. Well, we wouldn't leave it like that. I can distribute this 3 through to this group of parentheses because it's connected by multiplication. So we have a sub n is equal to 2 plus 3n minus 3. Combine your like terms, and you have a sub n is equal to 3n minus 1. Now, Ms. Cleveland, why would we bother to do that? This, instead of saying, okay, 2, and we're going to go up 3 plus 3 plus 3, what if I wanted the 5th term? Well, that's easy. We could do 2 plus 3 plus 3 plus 3 plus 3. Oh, it's 14. Okay, let's double check that. 3 times 5 is 15. 15 minus 1 is 14. Okay, but what if I wanted like the 100th term or the 1000th term? This process would get really cumbersome. Okay, really tedious. So it's really nice to have a formula that you can just plug in one simple number and it'll tell you what the term is. Okay, so don't forget to simplify it down to its simplified linear form. All right, let's do another one. Find the formula for the nth term. Remember, that just means a sub n, whose common difference is negative 8 and whose first term is 5. Okay, well, looking up at this formula here, our first term comes first, so this right here is 5. We always have plus n minus 1, then times the common difference. The common difference in this problem is negative 8. Okay, first term, common difference. Now, let's distribute the common difference. So we have a sub n is equal to 5. This right here is going to give us minus 8n, and a negative 8 times a negative 1 gives us a positive 8. Okay, so simplifying this a bit more, we have a sub n is equal to negative 8n plus 13. I personally like to check a few terms. So if the first one's 5, 5 minus 8 would give me a negative 3. So since this is the first term, the second term, let me plug in a 2 really quickly. Negative 8 times 2 would give me a negative 16. Negative 16 plus 13, boom, negative 3. Okay, I like to just do 1 or 2 just to make sure that I didn't make any mistakes in my formula. So that is correct. All right, flip it over. We would like to find the sum of a finite arithmetic sequence. Let's break that down for just a second. Infinite means it goes on forever. Finite means it ends. Okay, there's only going to be a set number of terms. Arithmetic sequence is a list of numbers where each term goes up or down by a common difference. Okay, so the nth partial sum of an infinite arithmetic sequence is this. Okay, let's break that down. Nth term, so we're going to have some number of terms, maybe the 8th term or the 10th term. And the reason why we call it a partial sum is because really that sequence would go on forever, but we're stopping it at a particular point. N is the number of terms we have. Okay, so if we have the 8th term, all of these n's would be an 8. If we wanted the 20th term, all of these n's would be a 20. A sub 1 is your first term. A sub n is your last term. Okay, so let's do example 4. Find the sum of this finite arithmetic sequence. First, let's make sure it's arithmetic. See, that would be plus 2, plus 2, plus 2, plus 2, plus 2. Okay, life is good. This is arithmetic, and the common difference is plus 2 each time. That's a good thing. So let's break down this formula up here. We want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. Okay, this is our first term. So let's call that a sub 1. This would be a sub 10. So let's just break down the things that we know so far. We know that a sub 1 is 1. We know that a sub n is 19. We know that in there are 10 different terms. So now we can plug everything in. Okay, so the sum of these 10 terms, remember I told you that n would be replaced by whatever your n is equal to n over 2. In this case, n is 10, so I'm just plugging it into this formula. Parenthesis, our first term is 1. Our last term, our nth term, is 19. Okay, so then you just do the arithmetic there. 10 over 2 gives you a 5. 1 plus 19 gives you a 20. And 5 times 20 is 100. So S sub 10 would be 100. And really quickly, you can double check me just to prove to yourself that it works. Okay, I'll do that really quickly. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Hallelujah. Okay, so you can see that it does work. All right. Let's try the next one. Okay, find the sum of integers from 1 to 100. Okay. So thinking through this, what would my a sub 1 be? Well, a sub 1 is the first term, so that's going to be 1. All right, what would be my a sub n, my nth term? Well, a sub n is going to be our last number, 100. But what is n in this case? How many numbers are there from 1 to 100? Well, 100. Okay, so once we have all of those pieces, we can plug this in. S sub 100 is equal to 100 over 2 times 1 plus 100. All right, so that's going to be 50 times 101. Plop that into your calculator really quickly, and you have your sum of your first 100 integers is 5,050. Okay. Now remember last class we brought in this equation here. Remember sigma was the shorthand for find the sum for integers produced by this formula from 1 to 32. Well, thankfully the formula still works. I mean, what we just did, the sum formula will still work. Okay, so rather than having to, like we did last time, do this all out, I will want you to show your work for this. I know that you can do this in your calculator, but this is one that I want you to show your work with. Let's talk about what n is, the number of terms. If we're going from 1 to 32, how many eventual terms would we have? Well, 32. Our first term, our a sub 1, you've got to figure out what that is. So if I were to plug a 1 in here, 3 times 1 plus 8, that would give me 11. Then we want to find a sub n. n in this case is 32. So let's find our 32nd term. So 3 times 32 plus 8. And pop that into my calculator. Let's see. 6, 9, 8. That's going to give me 104. Now I have all of the information that I would need. So the sum of these 32 things will be 32 over 2 times a sub 1 plus a sub 32. Well, it's going to give me 16. That's going to give me 1. Okay, so plug that in. So S32, when I plug that in, I get 1,840. Double check me. Okay, so this is why this formula is going to be really nice, okay? Find the 150th partial sum of the arithmetic sequence. This right here is what tells you what n is. That's all that means. Okay, so in this case, n is going to be 150. My first term, well, just look at the first thing in your list. That is a 5. Okay, but this is, your nth term is not 49. Be careful, that's going to be a really common thing here. But we need to figure out what this is going to be when we go out and out and out and out and out. Well, looks like we're going to have to find a formula for it because this problem doesn't automatically get me the 150th term. So let's use what we did on the other side, right? Let's use this, let's find out a formula so that we can figure out whatever term we want. So what would our common difference be here each time? Looks like our common difference is plus 11, and we know that our first term is is 5. So here we go. A sub n, we're trying to figure out an nth term, is equal to a sub 1 plus n minus 1 times our common difference, distribute. So a sub n is equal to 5 plus 11n minus 11. So our general formula would be 11n minus 6. So our 150th term would equal 11 times 150 minus 6. Plugging that into the formula that we just came up with. Plug that into your calculator and it looks like 1644. All right, now we know this piece, and as soon as we know that piece, we can plug everything in. N is 150, a sub 1 is 5, and now we know that a sub 150 is 1644. So let's plug that all in. The sum of the first 150 terms of this sequence would equal, let's go back to the formula here, n over 2. So that is 150 over 2 times our first term, which is going to be our 5, plus our last term, which in this case is the 1644. Okay, so now plug that all into your calculator, and I got that the sum of these first terms would be 123,675. Fantastic. All right, let's read over the next example so you understand what's going on. All right, so in this golf tournament, they're being super nice. You know how much I golf. I don't know if this is how it really works. Okay, but the first place prize is going to be 1,000. And every golfer is going to receive 950, 900, so on and so forth. So let's look to see what that looks like. Okay, so our first golfer gets 1,000. Then 950. then 900, and it says, and so on. So what is our common difference here? What's actually happening? Looks like to me it's going down 50, down 50. So look, there's our common difference, okay? We might need that in a moment. To find what is the total amount of prize money, this is what we're actually trying to answer. So what they're wanting us to do is to add all of these together. Well, that means we need to find a sum. So we're going to need n, a sub 1, and s sub n, or excuse me, a sub n. So let's see, n, the number of terms. How many terms are we going to have in here? Well, we're going to have one per golfer. So there's going to be 16 terms. Our first term in our list, well, that's 1,000. And again, I could keep doing minus 50, minus 50, minus 50 16 times, but I'm going to work smarter, not harder, and use my formula. So a sub n is equal to my first term plus n minus 1 times our common difference, negative 50. Distribute. A sub n is equal to 1,000 minus 50n. Negative times a negative gives you plus 50. So my general formula is negative 50n plus 1,050, right? Combining those two. So my 16th term would be negative 50 times 16. Let's see, plug that in, 250. So there's my a sub 16. Now I have everything I need. All right, so the sum of all of these pieces, s sub 16, equals 16 over 2 times my first term and my last term. Enter that all in. And the organizers of this golf tournament better have $10,000 to pull this off. That's the total prize money that they'll be spending. All right, so from this point, please make sure that you get the homework from the sub. Please make sure that you are staying on task, and I will check your 11-1 and 11-2 homework next time. I will be here Friday morning for tutorials, so if you need any help, come see me.